Welcome to the WAGAS Innovation Talks. This podcast offers you an insight into recent innovations in the tech business, driven by research and industry insight. We are talking to researchers and professionals to share their expertise, experience, and projects with us. As a think tank and accelerator, we support tech startups and corporations in growing their business. We believe innovation is key to growth and hope to shine light on academic research and experts with real-life industry experience. To learn more, visit wagas-group.com and find all our podcast episodes plus articles and resources to expand your horizon on tech innovations. My name is Olivia van Herde, Marketing and Sales Manager at WAGAS, and today is another special episode because we have two guests sharing their insight with us. I'm very excited to talk to Youval Nehmadi and Pierre Olivier from LeddarTech today about autonomous vehicles. Youval has over 25 years of experience in the high-tech industry, including in applied materials, algorithms, computer vision, deep neural networks, and business development in both large enterprises and startups. He holds a PhD in 3D sensor fusion for autonomous vehicles and an MBA from Kellogg Recanati of Tel Aviv University, and is the owner of more than 20 patents. In January 2016, along with Ronnie Cohen, Youval co-founded vison, a sensor fusion and perception software company focusing on the autonomous driving market. vison developed an innovative patented technology that enables best-in-class sensing with added value recognition abilities at an affordable price. In July of 2020, vison was acquired by LeddarTech, a global leader in Level 1 5 ADAS and AD environmental sensing technology. Today, Youval is the engineering director in sensor fusion and perception at vison, a LeddarTech company. Pierre is the CTO at LeddarTech. Recognized for his technical expertise as well as his vision, Pierre has numerous years of experience in the development of high-tech products. Upon graduating from university in 1991, he joined CML Technologies, where very early on his ability to manage projects in a pragmatic and efficient manner became clear. He quickly moved up the corporate ladder while developing his management skills. Pierre has also designed a number of innovative, adaptable, practical, and robust products that are used worldwide in strategic applications such as emergency dispatch and air traffic control, and he holds several patents for his work. He then continued his career at Adapt Technology Canada and at DAP Technologies before joining the LeddarTech team in 2010. Pierre holds a degree in electrical engineering from Université Laval and is a member of the Ordre des Ingénieurs du Québec. Welcome to the podcast, Youval and Pierre.
Hello. Hi, thank you.
So today's episode is about computer vision algorithms and autonomous vehicles. To start off, let's give our listeners an overview of developments in computer vision. Could you explain the latest advances in computer vision and the major milestones that have been reached in the past decade?
Yeah. So basically, it's I will start a little bit before actually. I will start a little bit when the first electronic brain model has been invented, and it was done on the 40. I mean, and it's not connected to computer vision at all. But later on, we will see how it came connected.
Fantastic. Yeah.
And then on 1957, there was the first computer scanning, and it's not so long ago. Computer scanner, to be able to scan an image into a computer, which this was even before there was a computer vision, and then there was the classic computer vision has been started. And on 1976, there was one application of the in the UK, the police invented a license plate recognition system. But think about it, this is only less than 50 years ago, and then suddenly everything started to develop very fast. And on the 1988, there was the first multi-layer perceptron, which is the first DNN. Everybody speak about the last decade that the DNA, deep neural network, has been started, but basically, things have been started before, and so there are many things which related to computer vision that has been started before, but the first DNN has been started on the 90s, and I even remember myself, in the 90s doing a DNN. The problem was that it took a lot of time. The computer were not strong enough to be able to, calculate so much calculation as being required in a deep neural network. But then, on then there were GPUs which were invented, and much stronger computer, and really in the last decade, a lot of things from a classical computer vision moved to much more easy, adaptable deep neural network, and it has been expedited very, very fast. For example, the AlexNet was done at that time, and so on.
All right. All right. Great. Thank you for that overview. And could you share your experience which brought you to fuse multiple raw data sources thereof shifting conventional computer vision algorithms?
Yeah, so this is really regarding, first I will speak a little bit about, what is the difference between, the regular way that the industry were working until recently, and a little bit what is the difference between this and the raw data fusion. So basically, the industry was working like that there is a camera, and then there is a perception on the camera, and there, there is a cognition engine which is sitting on the camera and calculating everything, and understanding where are the car, where are the pedestrian, and so on. And then there is a LiDAR, which again, there is a processing unit that is sitting on the LiDAR or on the radar that is also calculated everything. And the fusion was done as object level fusion. So basically, the result of each sensor were fused as object level. But this is suboptimal. I mean, basically, the problem with that you the SNR is not so good. So basically, for example, if you have mistake in the camera, let's say that there is a drawing on the road of a pedestrian. So you look at the road, the camera looking at the road, but it sees pedestrian. It doesn't understand that there is the 3D related to that. And the decision is that the car should stop. But if you have a LiDAR, the LiDAR see that there is no 3D. It's only a drawing, and he know that the car can continue. So it's very important to use the data in the beginning, fuse it together, and then take the decision. One time to take the decision. And it's also much better since it's saving the silicon, basically. So you have you don't need to have a calculating unit on each sensor, and then another processing unit to fuse all this information. So you have one a little bit larger ECU that calculate everything together.
Okay, I see. And why is it so important to fuse multiple raw data sources to enhance computer vision algorithms?
So a little bit I explained before. So when you have multiple sources, So
Yeah.
you get a little bit more understanding. I mean, for example, if you have for each pixel the 3D structure, so you understand your environment better.
Mm-hmm.
But additionally, when you understand better, it's safer. So basically, it's better to have a different modality that you will have a safer system.
Mm-hmm.
Additionally, in autonomous driving, you cannot have any mistakes. I mean, think about it. It's not like a level two. When the system is giving you warning or not giving you warning because you are driving. When you're
Yeah.
when you're driving autonomously, you cannot make mistakes. The system cannot make mistakes,
Mm-hmm.
and
Mm-hmm.
and then you also need redundancy, because let's say that one sensor is not working good enough or not working at all.
Yeah.
So, so if one sensor is not working good enough, so you can use the information from the other sensor to compensate that. And this is easy. The challenge is how to combine it when one of the sensors is not working good enough. For example, camera
Mm-hmm.
at night is not working good enough, or lidar when there is a specular reflection, so it can miss the target. So the challenge is actually how to uh, take all the information from all the sensor, from all the modality, and combine it together in one model that all the information about the environment exists, and then you don't make mistakes.
Now, LeddarTech uses upsampled high-resolution 3D models. Can you explain what that is?
Yeah. So as Yuval explained, you're dealing with multiple modalities. So let's take the simple example where you have a camera and you have a lidar. Uh, so the classical approach that Yuval was describing is you would process these two data sources separately, and you would do that with separate
Yeah.
algorithms, and you would come up with like the results from each, and then you
Mm-hmm.
try to combine them. So what the high resolution 3D model is basically you take these inputs and you combine them into, I think of it as a super sensor. So basically
Mm-hmm.
you take the depth information from the lidar, you take the color information from the camera, and then you build from that a an image that combines the data from the different sensors into this better quality and higher
Mm-hmm.
resolution 3D image. And then it's a very unique way of doing things, because then you can run all your detection algorithms, your classifiers, your object detectors on this image. So then uh, if you change a sensor, for example, or if you change the mounting location to
Mm-hmm.
adapt to a different vehicle, your model remains the same because it's a generic sensor. So that's really what it is, and it's a very, very powerful approach.
Now, in a previous podcast episode, a guest said the human driver is a bad driver. And autonomous vehicles are supposed to be more accurate and more reliable and more safe than human drivers, right? So, how can autonomous vehicle perception systems be more safe than human drivers?
That's a very good question, because actually the human drivers in actually work, they're quite good in most cases.
Mm-hmm.
There's a high number of accidents on the road, but if you
Yeah.
bring that into accidents per kilometer, it's
Mm-hmm.
very, very low.
Mm-hmm.
So really, and why that is the human sensors are quite good, the human eyes are quite good,
Mm-hmm.
but the human brain is very, very, very powerful,
Mm-hmm.
and it's much more powerful than any computer we can put on
Mm-hmm.
cars
Mm-hmm.
today. So really, accidents occur when the driver is distracted.
Right.
Uh, they occur when they're in impaired driving, like drunk driving,
Yeah.
or they occur when there's very difficult weather conditions.
Mm-hmm.
And that's really where autonomous vehicle or technology can help improve the overall reliability and safety is because they're not affected by these conditions. So so the key to that is in the processing. It's basically, how do you make processing that's reliable enough that it will be better than the human brain in all or most conditions. And that's been the biggest challenge of the industry. Some people think of it as a sensor challenge. It's not a sensor challenge. It's from our standpoint, it's a system challenge. It's a processing challenge. But it's a very, very tough problem to solve, because there's a infinity of different permutations and combinations and scenes and so on. And that's been what the industry's been trying to achieve for the last decade, using technologies such as Youval was describing earlier, by using neural networks to try and solve this.
And could you tell me a bit more about LeddarTech and ViaVision? So in July 2020, LeddarTech acquired ViaVision. Why was this an important step for LeddarTech's roadmap?
Well, I think you got portions of that in my previous answer. So originally, LeddarTech, we started out as a sensor company, and we continue to offer sensor sensor systems. But as I mentioned, overall, it's a system problem. It's not a sensor problem. So perception it's a key component of that overall system. So basically, bringing in that capability and integrating perception into our offering, it really allows us to offer a more complete solution to our customers. So that's what the reason for the acquisition was.
Thank you so much for your insight. We've reached the end of the podcast episode. Thank you so much, you two.
Thank you.
Thanks.
If you want to learn more about autonomous vehicles, listen to our podcast episode 11, featuring Ofer David and Dilly Edri from Brightway. You can read more at wagas-group.com. This has been your Innovation Talks podcast, produced by Olivia van Herde. Make sure to check back next month for the latest insight in innovation.